So in this lecture, we're going to wrap up our discussion of doing arithmetic with complex numbers by looking at division and exponents. So with division, we really have two motivators here. First, remember that I is really just kind of another way of writing the square root of -1. You remember, we kind of have a rule about not having square roots in the denominator. So just and for that reason alone, we would like to simplify this in such a way that we get the i's out of that part of the fractions. But remember, our second goal is when we're simplifying a complex number, we always want to have it end up in that basic a plus bi form. Okay, so that's what we're going to be trying to get at here. Now, remember, in the last lecture, we saw that interesting situation where when we multiplied a complex number by its conjugate, it turned into a real number. The imaginary part went away. And that's kind of our goal here with the denominators, is to make the imaginary parts go away, right? So that's how I'm going to handle this, right? For this first one, I'm going to multiply the top and the bottom by 1 minus 2i, right? If I do this, the top becomes 2 minus 4i. That's just distributing the 2 into the complex number. And if we multiply the bottom out, it's 1 plus 2i minus 2i minus 4i squared. You see, I'm going to get exactly what I want here. Those complex numbers, the 2i minus 2i, that's going to become 0. And the I squared becomes -1. So we end up with 1 plus 0 plus 4. So the denominator becomes 5, a real number. I's are gone. That's what I was looking for. Now, in my classes, I would accept this as an answer. Right? Some people, some teachers, professors may be a little more picky and really want it to look like something plus something I. So they might want you to split it up, right, and make it 2/5 minus 4/5 I. Really, at this point, I think they're both sufficiently equivalent that you could stop on the previous one. Okay, so how about this one here? We're going to do the same thing with the second one. It's going to be a little messy because we're going to have to multiply binomials in both the top and the bottom, but it is what it is, right? So I'm going to multiply the top and bottom by 2 plus 3i. Again, that's the conjugate, right? So the top, the numerator, becomes 2 plus 3i plus 2i plus 3i squared, right? The i's are not going to go away in the numerator, and I am perfectly fine with that, right? So in the denominator, we get 4 minus 6i plus 6i minus 9i squared. Okay, so in the numerator here, what is the 3i plus 2i? That's 5i. I'm going to replace the I squared with -1. So then we'll have 1 minus 3. So this is going to become, in the bottom, the I squared also gets replaced with a -1. Right? So the bottom, 4 plus 9 is 13. The i's went away. Excellent. And we end up with -2 plus 5i in the numerator. Right? And I'm going to stop here. If you want to split this up, 4/13 plus 5/13 I, that will be fine as well. Okay, so one last thing we'd like to be able to do is raise I to powers. And there are some really interesting patterns that show up here. All right, so let's work through some of these. I to the first, that's just I. I squared is -1. That's our definition. Okay, well, how about I to the third? Well, I to the third is I times I squared. I squared is -1, so that's just -I. Okay, so how about I to the fourth? Well, that's I squared times I squared, which is -1 times -1, which is +1. Okay, kind of interesting. We have some relatively simple outputs here, so that's nice. Now let's try a few more and see what happens. So if I try I to the fifth, well, that's I times I to the fourth. But remember, I to the fourth, that was just 1. So I to the fifth is equal to I. Okay, so how about I to the sixth? Well, that's I squared times I to the fourth. I to the fourth, still 1. I squared is -1, and we get -1 again. Okay, I to the seventh, you see a pattern coming here, right? Is I to the third times I to the fourth, which is -I times 1, -I. Finally, I to the 8th, that's I to the 4th times I to the 4th, which is 1 times 1, which is 1. And you notice we've got the same pattern repeating over and over again. If we try this again, I to the 9th, that's I times I to the 8th. I to the 8th is 1. We're going to get the same cycle of 4 numbers. Okay, so how could I do something like I to the 219th power? Well, here's what I'm going to do. I'm going to break that 219 up into a multiple of 4 plus something else. All right, that sounds a little strange. Here's how I'm going to do this. 219 is 4 times 54 plus 3. Okay, so split this up. This is I to the 4th to the 54th power times I to the 3rd. I to the 4th, that's just 1. So that whole first term there is just 1. I to the 3rd is negative I. And there's my answer. Okay, so if you're doing this in class, we're taking a test, right? Because I do that every time I teach these complex numbers. I have a question on there, I to some weird power, right? First, your answer will always be one of those 4 numbers. I, negative 1, negative I, or positive 1. And I'll tell you, when I'm taking the test, when I tell my students, when you're taking the test, the second I hand you that piece of paper, write those first 4 down. I to the 1st equals 1, I squared equals negative 1, I to the 3rd equals negative I to the 4th equals 1, and now you've got them there as a reference. You know you're going to have one of those numbers as your answer. Now, splitting that 219 up is a little weird. I mean, I'll admit. You divide 219 by 4, and you get 54 with a remainder of 3. That's kind of where that comes from. Okay, but look, here's the quick and dirty approach to doing this, and I shamelessly tell my students to use this. What is I to the 1,402nd power? Well, divide 1,042 by 4, and you get 260 with a remainder of 2. All I care about is that remainder. That remainder is going to give me my answer. This is I squared, which is negative 1. That's it. And we're done. Right? I don't expect you to do anything more complicated than that.